Here's the video for the Unit 2 practice test. So concept A is I can recognize patterns in sequences. So number 1 says, consider the sequence to the right, describe the pattern. So as we see, we have shapes where the number of sides is increasing. The first one starts with 3 sides. The next shape has 5 sides. The next shape after that has 7 sides. So in terms of what the pattern is, it seems like the number of sides is increasing by 2. So now it says to draw the next 2 figures in the pattern. Well, since I know I'm going to have a hard time drawing it, I'm just going to describe it's going to be a 9-sided figure and then an 11-sided figure. C says how many sides does figure 8 have? So let's just list out the terms. So we start with a 3-sided figure, then a 5, 7, 9, 11, 13, 15, 17. So that's 1, 2, 3, 4, 5, 6, 7, 8. So the 8th figure has 17 sides. So figure 8 has 17 sides. All right, number 2, we're determining the unknown term in each of the sequences below. So we have to identify what the pattern is and then go from there. So looking at A, it looks like we're multiplying by 2. So if I want to identify the first term, we want to know what times 2 would equal 12. Well, that's going to be 6. So that first term is going to be 6. All right, the second pattern, it looks like it's increasing. It looks like we're adding a 0 each time, but if you look carefully, it also looks like we're switching between positive and negatives. So that means we're going to be multiplying by negative 10. So one way you can identify when you're multiplying by a negative is that you have alternating positive and negative numbers. That's how you get a alternating pattern of positive negatives. So in this case, 6 times negative 10 is going to be negative 60. So that pattern is multiplying by negative 2 or negative 10. And this first one was multiply by 2. All right, C looks like it's increasing, but it looks like it's increasing at a slower rate, which tells me it's probably an arithmetic sequence. So we're adding a constant number. Well, if we go from 9.2 to 10.5, we add 1.3. And then that pattern also works between 13.1 and 14.4, adding 1.3, which tells me that the pattern is adding 1.3. So to get my next term here, 10.5 plus 1.3 is going to be 11.8. And just to check, 11.8 plus 1.3 would give me 13.1. All right, problem number 3, determine whether each of the following sequences are arithmetic, and then write the explicit formula. So remember, for something to be arithmetic, we need to be adding and subtracting by a constant term every time. So looking at the first one here, this is a decreasing function, which tells me if it is arithmetic, we would be subtracting. Well, the difference between 22.4 and 12.4 is negative 10. And let's see if that pattern works the rest of the way. 12.4 minus 10 gives me 2.4. So that works. 2.4 minus 10 gives me negative 7.6. That works. And lastly, negative 7.6 minus 10 gives me negative 17.6. So in that case, our common difference is negative 10. So yes, this is arithmetic. And to write the explicit formula, remember the explicit formula is AN equals A1, the first term, plus the common difference times n minus 1. So in this particular problem, this is going to be A1. So that's going to be 22.4. And my common difference is going to be negative 10. So we're going to do minus 10 and in parentheses n minus 1. All right, so let's look at B. We're determining if this is an arithmetic sequence. So let's see how it's changing. It looks like it's decreasing. Well, to go from 20,000 to 2,000, we subtract 18,000. And then to go from 2,000 to 200, we subtract 1,800. Well, right away, since I know that that's not a common difference, that means it's not arithmetic. So we're going to say no, because there's no common difference. And if it's not arithmetic, we're not going to be able to write an explicit formula for that arithmetic sequence. All right, question number 4 says determine the 50th term in the sequence defined by an equals negative 13 plus 6 times n minus 1. So we're trying to find the 50th term, which means that we are going to plug in 50 for n. So it's going to be negative 13 plus 6 times 50 minus 1. Okay, so of course we could just put this all in our calculator, but we could also simplify it in parts. Doing PEMDAS, we know we do parentheses first. So 50 minus 1 is 49. And then we're going to do multiplication. So we're going to multiply 6 times 49, which is 294. And we're going to add that to negative 13. So that gives me 281. So that tells me my 50th term is going to be 281. All right, so for these concept B, it's I can recognize and represent linear functions. So this next set of problems, it says I determine whether each of the following represents a linear function, and then we're going to explain the answer. So looking at A, we have a table, and we have an x and f of x, and if we notice, all of the values in the x column are 4s. So all the values in the domain are 4s. So right away, I know that this is not a function. So this can't be a linear function. So no, because this is not a function. Because 4 has multiple y values. And we're wondering if it's a linear function. So it obviously can't even be a function. All right, looking at B, we have another table here. So let's just see how this table is changing. So let's look at the x values first. To go from negative 3 to negative 1, that's adding 2. From negative 1 to 2, that's adding 3. And then adding 2, adding 6. So I already see that we don't really have a constant pattern, but let's look and see what's happening for the y values. Looks like for the y values here, we're adding 2. Well, in order for this to be a linear function, the x's and y's, the differences have to be constant. So I'm going to write no, because the x values aren't increasing. At a constant rate. So even though the y values are increasing at a constant rate, the fact that we have this plus 3 here, oops, I just realized I wrote plus 6 at the bottom, but this should say plus 2. So even though we have constant values here, the x values are not constant, so that's why it's not a linear function. Okay, looking at the next problem, so y equals negative 3x plus 2. Yes, this is linear because it's written in the form y equals mx plus b. All right, lastly, D, it says y equals 3 to the x minus 4, so this is going to be no. This is an exponential function. And I know that because x is the exponent. All right, this next set of problems, we're writing an equation to represent each problem situation. So it says Damon is earning money to go on vacation. He currently has $200 and he earns $21.75 an hour working as an engineer's assistant. Write an equation to represent this problem situation to find your variables. So I see that I have two different quantities. I see that we have a starting point and a constant rate of change because he's earning that for every hour. So this is going to be written in the form y equals mx plus b. M is going to be my slope or my constant rate of change. That's $21.75. And he starts with $200. So X represents the number of hours he works. And Y represents the total amount of money he has. All right, looking at B, it says Greta is selling plants for a fundraiser for her wrestling team. She sells ferns for $5 each and cactus for $7 each, and she hopes she will earn $450. So right away, I see that there's three different quantities here. We have a total amount, which is $450, and an amount that is kind of like a rate of change. So we're going to write this in standard form. So it's going to be 5x plus 7y is equal to $450. So X represents the number of ferns she sells, and Y is going to be the number of the plural of cactus is cacti. So number of cacti she sells. All right, concept C, we are identifying characteristics of linear function. So number one, for each function represented by the graph below, find the following characteristics and write its equation. All right, so for this one, we're going to identify the slope and the y-intercept. So first thing I'm going to do is identify the y-intercept. So that's at 2, which means my y-intercept is going to be 0, 2. And to find my slope, we're going to look along this line for the next point that we see, which looks to be right here. And then we're going to count the rise and the run. So to go from the y-intercept to that point, we have to go up 1, and then we have to go to the right 3. So my slope is going to be rise over run, so 1 over 3. So now writing my equation, it's going to be y equals 1/3 x plus 2. All right, the second one, finding my y-intercept, that's 0, 3, so that means b is going to be 3. And then to find my slope, I'm going to look for a point on the line, which it looks to be this one. And now I'm going to find my rise and my run. So for this one, we have to go down 4. Since we went down, that's negative, and right 1, that's positive. So my slope is going to be negative 4 over 1, which we could just write as negative 4. So my equation is going to be y equals negative 4x plus 3. All right, so now let's take a look at the next set of problems. So for these ones, it says we're identifying the characteristics, slope, y-intercept, x-intercept. So looking at A, it's negative 3x plus 5y equals 30. So that's written in standard form. So it's going to be easiest to identify the x and y-intercepts first. So to find my x-intercept, we're going to plug in y equals 0. Because remember, our x-intercept is written as something, 0. So we're going to solve for x. So negative 3x. 5 times 0 just ends up being 0. So it's just going to be negative 3x equals 30. And divide by negative 3. So x is going to be negative 10. So my x-intercept is going to be negative 10, 0. To find my y-intercept, we're going to plug in x equals 0. Well, negative 3 times 0 is just 0, so then you're just left with 5y equals 30. So you're going to divide both sides by 5. 30 divided by 5 is going to be 6. So my y-intercept is going to be 0, 6. Now to find my slope, we're going to sketch a picture of our graph. So my x-intercept is negative 10, 0. And my y-intercept is 0, 6. So I know that my line is going to look something like this. I know I have a positive slope, so we're going to find my rise first and then my run. So my rise, to go from this point to this point, I have to go up 6 units. And then my run, I have to go to the right 10 units. So my slope is going to be 6 over 10. And if you can simplify, you should. So 6 divided by 2 is 3. 10 divided by 2 is 5. So that's going to be 3/5. Second equation. All right, this equation is written in slope-intercept form, which means that I should be able to easily identify the slope. So my slope in this case is going to be, sorry, I don't know why my pen got so thick. The number in front of x, so that's going to be m equals 4. And then my y-intercept is going to be my constant term, but we're going to write it as 0, 7. To find my x-intercept, we're going to plug in y equals 0. So 0 equals 4x plus 7, and we're going to solve for x. So subtract 7. So I have negative 7 equals 4x, and then divide by 4. So x is going to be negative 7 over 4. So I'm just going to leave that as a fraction. My x-intercept is negative 7 over 4, comma 0. Okay, now we're going to determine if the function is increasing, decreasing, or constant. So starting with a, f of x equals 1/4 x plus 3. This is going to be increasing, and our reason is because our slope is positive. F of x equals negative 6x. That's going to be decreasing, and our reason is because our slope is negative. Lastly, we have f of x equals 7. That's going to be constant. And the reason is because there is no x. All right, D, this is a completely flat line, so that means that this is a constant function. And our reason is because it's flat. E, this is a decreasing function because it's going down. And F, this is an increasing function because it's going up. All right. Lastly, concept D, I can graph linear functions. So it says graph each of the following linear function using any method you choose. Explain your method. So A, this one is written in slope-intercept form. So I'm going to find my slope and my y-intercept. So my slope is going to be negative 3. My y-intercept is going to be 0, 5. So my slope of negative 3, I'm actually going to go negative 3 over 1. So that means I'm going to go down 3. And then I'm going to go to the right 1. So from my point, I'm going to go down 3, 1, 2, 3, and to the right 1. And I'm going to keep doing that to the end of the graph. And I'm going to go also in the same and in the opposite direction. So I'm going to go up 3, left 1. So up 3, left 1, and then I'm off the grid. So from here, I can connect my points. Okay, so to explain your method, I'm going to say I'm going to start with the y-intercept at 0, 5. Then use the slope and go down 3, right 1. All right, so now we have our last question here. We have negative 3x plus 4y equals negative 24. So this is in standard form, so I'm going to graph my x and y intercepts. So starting with my x-intercept, I'm going to plug in 0 for y. And we plug in 0 for y, that term disappears. So we just have negative 3x equals negative 24. Divide both sides by negative 3. So x equals 8. So my x-intercept is going to be 8, 0. Now to find my y-intercept, we're going to do the same thing, but we're going to plug in 0 for x. And when we do, that first term disappears. So we left with 4y equals negative 24. Divide both sides by 4. So x is going to be, y is going to be negative 6. So my y-intercept is going to be 0, negative 6. So from there, I'm going to graph my line And to explain my method, I'm going to say we find x-intercept by plugging in 0 for y. And then we found the y-intercept by plugging in 0 for x. And then we graphed both intercepts.